I know it's Monday, guys, but come on. Not quite. What's another name for a radical? What's this symbol? Square root. That's another name for a radical. So if it's a perfect square, it has something to do with a square root. What's the connection? Nope. Okay, just so for reference, perfect squares 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. What do they all have in common? If I take the square root of those numbers, what would you get? Not a perfect square. What's the square root of 4? Square root of 9. Square root of 16. What do all those numbers have in common? They're whole numbers. They're not any weird decimals or irrational numbers. That's what a perfect square is. If you took the square root of that number, it will give you a nice value. All right, you guys need to know that. Because difference of two squares, which the acronym that you'll see is DOS, or you might see it as DOTS. So DOS is difference of squares, DOTS is difference of two squares. All right. You will recognize these because they have two terms. So it's a binomial, a minus sign between the terms, and each term is a perfect square. So you guys remember that gold reference chart that I gave you guys a while back? All those numbers on there are your perfect squares. All right, so if you see any of those numbers on there and it's a binomial, that may give you a clue that it's a perfect square. So just to recap, some of your perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. That's just 1 through 10. All right, you guys should know 1 through 20 because I gave you that reference sheets, which you guys will have access to on the test. So make sure that you hold on to that bad boy. Now, there's also variable perfect squares. So the most common one, x squared. But we also have x to the 4th, x to the 6th, x to the 8th, x to the 10th, x to the 12th, and so on. What's true about all of those exponents? Why are they considered perfect squares? Look at the exponents of all of the ones I just listed. What do they have in common? They're even numbers. So if they're even numbers, that means that they're divisible by what? 2. All right, and that's exactly how you know if it's a perfect square. So variables that are perfect squares, the exponent is divisible by 2. That's also how you take the square root. So the square root of x squared is x. Square root of x to the 4th is x squared. Square root of x to the 6th is x cubed, and so on and so forth. So this would be x to the 4th, x to the 5th, x to the 6th. So all you do is just whatever the exponent is, you just divide it by 2. All right. So if you have an even exponent, it's automatically a perfect square. All right. The numbers you just have to remember. Now, if we look here, here's some examples. So this will typically be what you see. If you notice, x squared, perfect square. 4 and 36, also perfect squares. And they're both separated by minuses. So difference of two squares is literally what it sounds like. You're subtracting two perfect squares. And then right here is how you would actually FOIL them. What do you guys notice about the foiling or the factoring? Sorry. So what do you notice about how those two binomials are factored? So let's look at this first one. So we have x squared minus 4. And it's factored as x plus 2, x minus 2. What do you notice? What do you notice about the way it's factored? So look at the original. So what I have highlighted, x squared minus 4. And then look at the components that make up the factors. Right. So plus minus, that is part of it. What else? Why would I bring up perfect squares? Why do you think I would? So we got x squared and 4, and then the factors are made up of x and 2. What are the connection? 2 squared equals 4, and? So 2 squared equals 4. What about x? X squared is x squared. So in other words, if we took the square root of these two numbers, they would give us these values respectively. All right. So essentially, what you do is you place the square roots of the first and last term as the first and last term in the parentheses. All right. And then you separate them by pluses and minuses. So then you separate one with a plus and the other with a minus. Because what will happen is, let's say I did a quick FOIL on x plus 6, x minus 6, or box method, whatever. X squared, 6x, negative 6x, negative 36. What happens right here? So what happens with my x values? I got 6x minus 6x. What happens? They cancel out. And that's what should happen. That's why we alternate the signs. We want those x values to cancel out. All right. So the general formula, just so you're aware, the general formula for difference of two squares is that if you're given a squared minus b squared, you will factor it as a plus b, a minus b. So this right here is the formula that you need to remember. Now, let's give this a shot here. So, yes.
Okay, can I see that formula one more time? Okay, thanks. Is that a plus b, a minus b? Okay, thanks. That's right.
All right, so let's look at example 1. First off, is m squared a perfect square?
Yes.
Is 49 a perfect square?
Yes.
Are they being subtracted? Yeah. So we have a difference of two squared. So we have a squared minus b squared. Now, to factor, all you got to do is just figure out what those square roots are, so what a and b are. So I want to take the square root of the first and the square root of the last. Don't include the negative in the last. So what's the square root of m squared?
M.
M. What's the square root of 49? 7. So remember to factor plus here minus here. You put your first term or your a value first. So m is going to go first. B value is 7, so 7 goes last. And that's all there is to it. It's completely factored now. Now, let's say this was the test day and you completely forgot this formula. Another way you can do is just factor it like you would a trinomial. So, if we did a quick big X, what's A times C in this case? So this is A, this is C. Because remember, we're putting it in the form ax squared plus bx plus c. So since there's no x value, the 49c. So what's A times C? 49m squared. What's my b value? If there's not a b value, we put what as a placeholder? 0. So we're going to put an m here and m here. Now, what are two factors of 49? Or actually, it's negative 49. That will add to 0. So remember, if we're multiplying to a negative, that means one of our values is negative. 7 and negative 7. So if I do a quick, let's do a t method. So I have m squared plus 7m minus 7m minus 49. All right. What's the GCF of the first group? M. So I'm left with m plus 7. What do I do next? Bring down the negative sign. So that means my GCF is going to be negative. Well, what is that GCF? Negative 7. So if I divide negative 7 by negative 7, that's positive m. Negative 49 by negative 7, that's positive 7. We did it correctly because my bubbles are the same. So one of my factors is guaranteed what? M plus 7. That goes away. What am I left with? M minus 7. Did I not get the exact same thing that I got over there? Yes. So again, if all else fails, if you forgot that formula, you can treat it like you're factoring a trinomial. Guys, heads up. Come on. All right. So I'm not going to do that for all of them. I'm just telling you that if you forget, that's something that you can do as a backup. Next one. All right. So is 4t squared a perfect square? Yeah. So that's my a squared. Is 25 a perfect square? Yep. That's my b squared. And we're definitely subtracting them. So I need to get a and b. So what's the square root of 4t squared? 2 what? 2t. So square root of 4 is 2. Square root of t squared is t. What's the square root of 25? So what my two factors be? So what my two factors be? 2t plus 5 and 2t minus 5. Good. So guys, whenever you do a difference of two squares, when you draw your bubbles, just go ahead and put a plus minus in the middle. All right? And then you just put those two values on either side. In my opinion, difference of two squares, that is the easiest thing in the world to factor, but that's the one that most people screw up. Now, this one is a little bit different, but still difference of two squares. Is 64 a perfect square? Is m to the fourth a perfect square? Yeah, it's an exponent divisible by 2. It's a perfect square. Is 9 a perfect square? Yes. Is p to the 6 a perfect square? Yep. That exponent's divisible by 2. So, still business as usual. Take the square root of both, get a and b. What's the square root of 64? What's the square root of m to the 4th? M squared. You just divide that exponent by 2. What's the square root of 9? 3. What's the square root of p to the 6? P to the 3rd. Just divide 6 by 2. So, if I factored this, it'd be what? So 8m squared on the left of the signs. What goes on the right of the signs? 3p cubed. So as long as you can recognize your perfect squares, you're fine. And again, they have to be subtracted. If they're being added together, you can't factor them like a difference of 2 squares. Keyword, difference. Difference means subtraction. If you're not subtracting, you can't use the formula. Try example 4 on your own. So identify your perfect squares, take the square root of each term, and put it back into the formula. Again, if you want that yellow sheet out for reference with your perfect squares on it, might be a good idea. Trust your gut. Remember, just finding A and B, you basically have a factor. You just got to separate the 2 terms by a plus and a minus. If you think you got an answer, compare with your group. All righty, my dears. Let's come back together. So let's go with Nick. Is 169r squared a perfect square? Yes. So that's a squared. So if I took the square root of that, Nick, what do I get? 13r. All right, let's go with Wendy. Is 256 a perfect square? Yes. If I take that as a square root, what do I get? Not 13. 16. All right. So let's go with Rajan. How would this look factored now that I have my 2 terms? Nope. Mm-hmm. Uh-huh. There you go. That's all there is to it. So these problems are extremely easy. You just got to remember the formula. All right. Now, that's difference of squares. Now, we also have the perfect square trinomials. Now, we talked about this when we did completing the square, because turning a polynomial into a perfect square trinomial was the whole goal of completing the square. All right. Now, you'll recognize because the factors into a binomial times itself. And the patterns that you will see are in the trinomial are this. So, we have a squared plus or minus 2ab plus b squared. That's what a perfect square trinomial typically looks like. That's the formula. The reason I put plus or minus here is sometimes it's a positive, sometimes it's a negative. Now, the way it factors is that it'll be a plus or minus b all squared. Because remember, that's the same thing as a plus or minus b times a plus or minus b. Now, that may look like a lot, but in reality, it's not too bad. So, what it looks like is a and b are perfect squares. So, these are perfect squares. So, your first and last term are going to be perfect squares. Your middle term is going to be twice the product of a and b. Meaning, if you took the square root of the first and last term and you times those two square roots by 2, that's what you would get in the middle. So, how do I factor this? Well, let's look. So, the way you can see if it's a perfect square trinomial is first off, you check to see if your first and last terms are perfect squares. Are my first and last terms perfect squares? Yes. So this is a squared, this is b squared. Now, let's say that I took the square root of these. What's the square root of a? X. What's the square root of 9? 3. So if I multiply x times 3, what is that? 3x. And then what's 3x times 2? 6x. Is that not what we have as our middle term? Yes. So that is my 2ab. Now, the factoring, we've already done the first step. That first step being square root the first and the last term. And then our sign is going to be the sign of the second term. So this will be plus x3 squared. And remember, this is the same as x plus 3 times x plus 3. So, guys, if you forget like what a perfect square trinomial looks like, that's okay. Just do big X. All right? If you looked at this problem and I didn't tell you it was a perfect square trinomial, what would your gut instinct be to do? Not divide. So, go.
My gut instinct would be the factor.
Right, just factor with big X. All right? So if you didn't recognize this perfect square trinomial, that's okay. Just use big X. You'll get it. All right? I'm just saying that this is a shortcut if you do recognize that it is, but that's okay if you don't. All right, so this is also a perfect square trinomial because the first term is perfect square, which is x squared. The last term is a perfect square. So, what's the square root of the first term? X. Square root of the last term? 7. So, is 7 times x times 2 14x? Yep. So, if I factor this, what would it look like? X plus 7 all squared. All right, let's look at this one. first off, is my first and last terms perfect squares? Yes, so let's take the square root of them. So what's the square root of 9x squared? 3x. Square root of 16? 4. What's 3x times 4? 12x. Is 12x times 2 24x? Yep. So, and remember your sign's a plus in the middle. So what is this factored? 3x plus 4. Now, if this sign was a minus, if the second sign was a minus, this sign would be a minus. All right, just know that you always keep whatever the sign is in front of the second term. All right, now, the zero product property, once again, this is for solving. It's if the product of two factors is 0, then at least one of the factors is equal to 0. So, in other words, you make sure that you have all the terms on one side of the equal sign. So you need to get ax squared plus bx plus c equal to 0. And remember, if you're missing a bx term, that's okay, as long as it looks something like this. You set equal to 0, you factor it, and then you set all your factors equal to 0 and solve. So let's look at example 10. What type of special case is this? Is it a difference of squares or a perfect square trinomial? It's a difference of squares. All right, we have two perfect squares, subtracting them. So this is my a squared. Crap. This is a squared minus b squared. So what's my first step to factoring? Because it's r equal to 0. Finding the square roots. So what's my a value? 6x. Square root of 36 is 6. Square root of x squared is x. What's my b value? 7. Square root of 49 is 7. So if I was to factor this, what would it look like? Mm-hmm. 6x minus 7. You only got to change the middle sign. Yep, still equal to 0. All right, someone who has not talked yet, what's my next step for solving? We got it factored, now we got to solve. So what do I do next? I'm going to set both of these equal to 0 and solve. So let's do the left one first. What's my first step for solving? Come on, guys. I know you can solve a two-step equation. What's my first step? Minus 7 to both sides. Is a 6x equal to negative 7. What's my last step? Divide by 6. So x is equal to negative 7, 6. What about this one? What do I do first? Add 7. 6x is equal to 7. Then what do I do? Divide by 6. X is equal to 7, 6. So, if you notice our two answers, they are literally the positive and negative versions of each other. That's true for any difference of squares. You should get the positive and negative version of the same number. Yes, sir. Yes. So, the way I can fancily write this is I can write x is equal to plus or minus 7, 6. Meaning I got both the positive and the negative version of that answer. Now, if you just wrote it as the two separately, I wouldn't count it wrong either. I'm just saying that's how you can shorthand it. All right, look at example 12. So, at first glance, which one do you think this would be? A perfect square trinomial or a difference of squares? Trinomial. First off, it's a trinomial, all right? So let's check to see if it actually is. So are my first and last terms perfect squares? Yes, they are. So let's take their square roots. So what's the square root of 4x squared? 2x. Square root of 81? 9. What's 2x times 9? 18x. Is 18x times 2 36? Yes. So we got a difference of 2 squares. Now, take into account that this second sign is a negative. All right, so what would my factoring look like? 2x minus 9. Make sure you bring whatever the second sign, the sign of the second term is, down. I'm going to set that equal to 0. Now, I can leave it just like this to solve. You don't have to separate this. Because what's the first step to solve? Nope. Got to get rid of something else first. What's preventing me from touching what's inside the parentheses? Yet. The square. How do I get rid of a square? You square root. So I'm going to take the square root of both sides. What happens to the square and the square root on the left? They cancel each other out. So I'm left with 2x minus 9 is equal to, what's the square root of 0? 0. So perfect square trinomials are a rare case where you will only get one answer. All right. So all the other quadratics that we've dealt with so far, we got 2 answers. This is a rare case where you're only going to get one answer because you'll get the same number regardless if you separate the 2 factors or not. So now I can add 9. So that's 2x is equal to 9. And then I do what? Divide by 2. So x is equal to 9/2. So if you guys get one answer, that's okay. Remember, a quadratic can have anywhere from 0 x-intercepts, 1 x-intercept, or 2 x-intercepts, which x-intercepts are solutions. This is one of those rare cases when we only have one. All right? So, even if your factors, so for example, if I did expand that, 2x minus 9, 2x minus 9 equal to 0. Even if I separate those, they're the exact same equation, so we'll get the same answer. All that means is if you get the same answer for both of your equations, you just have to write it one time. All right. Any questions on the special cases? All right. Now, multi-step factoring. So, with multi-step factoring, this is where that factoring chart that I gave you will come in handy. And I also gave you a mini copy to go in your journal. That should be in your glossary. So, look at that factoring flow chart real quick, whether it be the one in your journal or the pink one in your that I gave you by hand. So, I like this flow chart because it really does a good job breaking down how you should go about factoring something every time. First things first, whenever you factor anything, what's the first thing you always check for? GCF. You always check for a GCF first. You may have one, you may not, but if you have one, you better factor that out first. Because I can guarantee you it'll make your factoring 20 times easier, whether it's a trinomial, binomial, or a 4-term polynomial. Now, from there, you look at how many terms you have left after you factor out the GCF. All right? So you look at the whatever you have in the parentheses. If you have 2 terms, you need to check for a difference of squares. It may not always be a difference of squares. If it's not, you're done factoring. If you have 3 terms, all right, you go to big X. Big X and then T method or reverse box. If you have 4 terms, you're going to factor by grouping. All right, so remember that's just the T method. You just don't have to do big X. Or reverse box just without the big X. Now, after you do that part of the factoring, the last thing you need to check for, because sometimes they're sneaky about this. Sometimes when you factor, especially when you factor by difference of 2 squares or grouping, all right, sometimes they throw in a binomial factor that's a difference of 2 squares. They throw in another difference of 2 squares. If that's the case, you got to factor that factor as well. All right, so just be careful about that. Sometimes they will throw that in there for you. And again, it's mainly, this may happen mainly if you do this one or this one. The trinomial, not so much. So just be careful. Then, if you think you've done factoring, so you don't have any more GCFs, you don't have any more difference of 2 squareds, you don't have anything else you can do, then your polynomial is completely factored. And remember, you can always double check your work by doing a quick FOIL or box method back. All right, so back to here. So again, you take out GCF first. 2 terms, you look for a difference of squares. 3 terms, you do big X. Then you pick. You can either do T method or reverse box. 4 terms, that's just grouping. And again, that's just a straight up T method or reverse box. You don't have to do the big X beforehand. Now, when it says look for any more factoring, specifically, that means double check to make sure you don't have any more difference of 2 squares. They love throwing those in. Yes. Yeah. All right, so let's try some of these examples. So let's look at example 13. Now, if you were looking at this, what would be your gut instinct to start with? So, like, if you just looked at it and you just knew what we knew about factoring, what would this look like to you? What type of factoring problem would this look like to you? Like a difference of 2 squares, right? But is 8 and 72 perfect squares? Are 8 and 72 perfect squares? No. All right. However, is there something I could take out to make perfect squares? Yes, I have a GCF here. That's why I say always look for a GCF first. What's a GCF of 8 and 72? 8. So the GCF is 8. So I'm going to divide both of these terms by 8. So remember, don't forget to put the 8 on the outside. What's 8x squared divided by 8? X squared. What's negative 72 divided by 8? Negative 9. Now, what does this look like to us? Is that a difference of 2 squares? Yeah. X squared and 9 are now difference of 2 squareds. So I can square root this one, square root that one. What's my A value? B? 3. So this factored will look like what? X plus 3, X minus 3. And I'm missing one last thing for my factoring. What am I missing? There's one thing. This is part of my final answer, but I'm missing one itsy bitsy teeny little thing. What am I missing? Nope. Not solving. What did I take out at the beginning? The 8. So I got to make sure the 8's in my answer. If you take out a GCF, you got to make sure that GCF is in your answer. Factoring wise, that's the biggest mistake I see. Whenever they take out GCF, you don't bring it down at the end, especially with multi-step factoring. So that was just one where you had to take out GCF. Let's look at this one. Now, this is a prime example why I tell students check for GCF first. Because if you just did straight into big X from this one, the numbers would be insanely big. But what's the GCF here? What's the GCF? 5. Hint, hint, wink, wink. More often than not, the GCF is whatever the A term is. It's not always true, but for the most part, it is. All right. So if you ever want to know like where to start, that's a good place to start. See if the A term will divide into all 3. So I'm going to divide all of these by 5. So 5's going on the outside. What's 5x squared divided by 5? X squared. What's negative 50x divided by 5? Negative 10x. What's 125 divided by 5? 25. All right. From there, we can do a big X for this. What goes on top? A times C, x squared. So what is that? What's A times C in this case? 25x squared. What goes on the bottom? Bx, that's negative 10x. So we have 2 x's over here. If I'm multiplying to a positive but adding to a negative, that means my signs of my factors should be what? Nope. They should both be negative. It's when you're multiplying to a negative that they're different. But if we're adding to a positive but multiplying to a negative, they're both negative. So, what are 2 factors of 25? I'll add a 10. 5 and 5. So, which way do you guys want me to do it? Reverse box or T? I heard reverse box first, so I'll do that one. So I'm going to rewrite it first by replacing the negative 10 with the negative 5x's. So if I reverse box this, I have x squared in the top left, 25 in the bottom right, negative 5x, negative 5x. What's the GCF of my first row? X. What's the GCF of my second row? Take note of the first sign. Negative 5. Don't forget, if you're doing reverse box, if the first box nearest to where you have to write your number is negative, you take a negative out. GCF of my first column, X. GCF of the second column, negative 5. So I have X minus 5 times X minus 5. And make sure you bring the GCF of 5 down. What's a way I could rewrite this? What's a way that I could rewrite those 2 binomials shorthanded? All right, X minus 5 squared. So that actually was a perfect square trinomial. So that's an example of if you didn't recognize that was a perfect square trinomial, just do big X, you'll end up with the answer anyway. All right. Let's look at this one. So, based off of how many terms there are, what do you think I'm going to be doing? Grouping. Good. So, I'm going to do T method for this one. Remember, you can also do this using reverse box. You could just go straight into reverse box. So, what's my first step? Or what's my first GCF? X what? Squared. Within this group, they both have x's. The lowest exponent is a square, so the GCF is x squared. So if I divide, Lord, I'm going tongue-tied. So if I divide both those terms by x squared, what's 2x cubed divided by x squared? 2x. What's x squared divided by x squared? Not x. 1. So that's my first grouping. What do I do for the second group first before I do anything? Bring the sign down. So remember, bring the first sign down. So our GCF is going to be negative. So what's my GCF of negative 18x and negative 9? Negative 9. So I'm dividing both of these by negative 9. That's why I tell you guys, bring that sign down. It forces you to make sure you pull out a negative if you have to. All right. So what's negative 18x divided by negative 9? 2x. What's negative 9 divided by negative 9? Positive 1. So what's guaranteed one of my factors? 2x plus 1. So I can cross those out. What am I left with? X squared minus 9. Now, here's my question. Am I done factoring? No. Why? Well, it doesn't matter if they're not the same. But there is a reason why we're not done factoring. Can anyone identify why?
Not the same sign.
The what? What part of the 9? It has to do with that factor. Technically, that's part of it. What is this called? You're on the right track, Rajon. What's it called? DOS. What does that stand for, DOS? It's a difference of squares. There you guys go. So that factor is a difference of squares. So we got to factor this factor. So you guys got to be on the lookout for that. Sometimes I told you they like to throw these in. All right. So I want to find my A and my B. I'm going to square root the first and the last term. We can leave the 2x plus 1 alone. We're just doing the x squared minus 9. So what's the square root of x squared? Square root of 9? So what would be the two factors? X plus 3, x minus 3. Now, in order to complete my factoring, I then have to do what? There's something I'm missing for my final answer. That 2x plus 1. Make sure you bring it down. So guys, again, especially with factoring by grouping, they love to throw differences of squares in there. So make sure you double check your factors that you don't have a difference of squares because they will throw one in there at you. I can guarantee it. All right. Let's look at this last one. It's definitely a difference of 2 squares because 32 is divisible by 2. So we start by finding our A and B. What's the square root of x to the 32 power? Remember, just divide that exponent by 2. So it'll be x to the what? X to the 16th. What's the square root of 1? So what's my answer? X to the 16 plus 1, x to the 16th minus 1. Am I done factoring? Nope. Why? Why am I not done? We got another difference of squares right here. So I want to bring down the x to the 16th plus 1 because I can't do anything with that one because of the plus. But I can do another difference of squares factoring with the second factor. What's the square root of x to the 16th?
X to the 4th.
X to the 8th, actually. So even though 16 is a perfect square, we just divide that exponent by 2. What's the square root of 1? 1. So this is x to the 8th plus 1, x to the 8th minus 1. Am I done factoring? Nope. Why? Still got another difference of squares. Oh yeah, we're going to do this for a minute. So I bring down the 2 factors that I already have. So I don't forget to bring them down at the end. And then I do another difference of squares factoring. What's x to the 8th square root? X to the 4th. What's it? 1, or square root of 1, sorry. 1. So x to the 4th plus 1, x to the 4th minus 1. Am I done? Nope. Another difference of squares. So have to square root that one. Make sure you bring down your 3 finished factors. Take my square roots of my last. What's the square root of x to the 4th? X squared. Square root of 1. 1. This is x squared plus 1. X squared minus 1. Am I finally done factoring? Nope. I got one more difference of squares. This should be the last time, though. So, make sure you bring down your 4 other factors. And then we're going to take care of this last one. Square root, square root, square root of x squared, square root of 1. This should be x plus 1, x minus 1. Now we're finally done. We have no more difference of 2 squares. So this is one of those guys where you really got to pay attention because we had to take a difference of squares since the first time 1, 2, 3, 4, 5 times. All right, so you really got to pay attention to that. Now, the solving, it's just more of the same. All right, do I need to do any example with the solving with multi-step? Are you good? Okay, so that's it for today. You got a new Delta math for homework. So you guys got a solid 15-ish minutes. You got at least enough to start it. Go ahead and get started. Yes. Yes. So guys, be careful with that multi-step factoring. It will throw you off.